Hello, friends. This is Jim with Science Talk. I want to share with you some studies that look at the global water supply. And this may sound paradoxical, but hopefully you'll see why. So, global water supply shrinks in a rainier world. The global water supply is dwindling even though rainfall is heavier. Once again, climate change is to blame. And so, wait a second, if it's raining more, how can the global water supply be dwindling? Well, it turns out, and I'll give you kind of the summation now, then I'll give you the specifics. Let's just say an area typically gets, I'm just making this up, 20 inches of precipitation a year. And let's just say, you get, 2 inches of rain for like 9 months out of the 12 of the year. And then for the other 3 months, you get the other 2 inches of rain. So in other words, the precipitation, whatever it may be. In other words, the precipitation is meted out in little bunches. So it can be captured, used, so on. Now let's say that climate changes, and let's say that same region now gets, say, 30 inches of precipitation instead of 20. You're like, ooh, 50% more, Well, what if now the changes are such that instead of getting like 2-3 inches every month, you go for periods of where you don't get any precipitation. And all of a sudden, boom, bam, bang, in 5 months you get your 30 inches. What's going to happen? A lot of that water, precipitation, is just going to run off and not be captured. And the runoff can then cause erosion. That's basically kind of where this is going. So let's get into the specifics here. Even in a world with more intense rain, communities could begin to run short of water. New research has confirmed that in a warming world, extremes of drought have begun to diminish the world's groundwater. There's another thing. You're not going to recharge the aquifers. Ever more intense rainstorms will do little to make up the loss in the global water supply. Okay, when you have rain that falls in steady amounts, the ground can absorb that moisture. It can absorb, the water can percolate through. It can refill the aquifers. Whenever it just comes all down at once, the ground gets saturated. It can't absorb much more water, and water runs off. And whatever the water the ground was able to absorb, most likely will not be sufficient to recharge the aquifers. That's in essence what's being described here. A second separate study delivers support for this, what seems kind of be a bit of a paradox. Rainfall patterns, there's evidence that rainfall patterns are increasingly being disturbed. You're warming the air, so you're going to change a water vapor distribution pattern around the planet. You're going to change maybe oceanic currents and flows, that atmospheric movements of air, how the air, the moisture is moved around, the jet streams and things like that. You're going to start changing all these things. And by the way, there is an active area of research looking at the hypothesis that the jet stream is changing, which means that the weather in the short term, right? Short-term weather is going to get really crazy. Right? Now we get, instead of the tight polar vortex that keeps us at 55 below for weeks on end, now it dips down so that the folks in Georgia and South Carolina can enjoy the wonderful cool temperatures we get to enjoy here in Alaska. But in all seriousness, that's the kind of stuff that's going on. So that's what the base is saying, is that rainfall patterns are being disturbed worldwide, and this is most likely due to the changing patterns of the distribution of the water vapor, how the air movement itself, vertical, horizontal, and so forth. The number of record-dry months has increased overall. So has the number of record-breaking rainy months. Just like my little scenario. Instead of being evenly distributed a little bit of time over the year, you get periods of where nothing happens, and then all of a sudden, bang, all at once. So instead of, you get these huge bursts, right? So, based on meticulous analysis of piles and piles of data, basically from ground data, groundwater data, they were able to provide substance to a 40-year-old prediction of climate change research that in a warming world, those regions already wet will get more rain, those areas dry will get more arid. You've heard me discuss that finding with you many times before. As global temperatures continue to incrementally increase, they've already gone up 1 degree C in the past century. That's conservative. A lot of other studies showing 1.3. It could be set to reach 3 degrees C by 2100. That's also conservative. Other studies predict 4. So that's the capacity of the atmosphere to absorb more moisture. I just did a video segment about water vapor, right? Warmer air temperatures can hold more moisture. So, if the atmosphere can absorb more moisture, guess what? More precipitation can happen, right? But while this is happening, more groundwater evaporates. And that groundwater is the aquifers. So if you're a person that you have a well at your house, right, you have to drill down to sink the well. You basically did what? You drilled down to hit that aquifer. And you run a little pump down there, pumps it into your house, and so forth. Well, those aquifers are going to start running dry. And then what? You won't have water in your house. So, Australian scientists report in the journal Water Resources Research that they studied readings from 43,000 rainfall stations and 5,300 river monitoring sites in 160 countries. That is an impressive, thorough, extensive study. They confirmed that even in a world of more intense rain, drought could become the new normal, and those regions are already at risk of becoming dry. This is something that has been missed. Okay, this is a statement from Ashish Sharma, who's an environmental engineer at the University of New South Wales. We expected rainfall to increase since warmer air stores more moisture, and that is what climate models predicted too. What we did not expect, despite all the extra rain everywhere in the world, is that the large rivers are drying out. We think the cause is the drying of soils in our catchments, where once these were moist before a storm event, allowing excess rainfall to run off into the rivers, they now dry and soak up more rain. So less water makes it flow. So we got two things going on here. You have dry, basically riparian. Riparian zone is the zone associated with streams, rivers, and that kind of stuff. It could be 10 meters on either side of the river, or 50 meters, 100 meters, whatever. But that's a riparian zone. You can see change in vegetation and so on. So what they're saying is that those areas immediately adjacent to the rivers are drying up, so the water goes there instead of the ground being already wet because it's next to the river. And therefore, when it rains, it just simply flows in the river, right? River levels come up. How many times you say, oh, the rivers are up because of excessive rain, snow melt, what have you. So that's one case. The other case is when you get away from riparian zone, you have the evaporation, the soil is drying out, and then the groundwater starts to evaporate and the aquifers get depleted. That's another situation. Or even then, okay, instead of the rain being meted out little by little, you have it all come at once, the ground can't absorb it, it runs off. Then you get erosion. So basically, more rain is meaning more problems because of when you look at the partial pressure, there's more evaporation from bodies of water. In addition to warmer atmosphere, you have more evaporation. More evaporation, more rain, but now the ground's drying out and we get these problems I just described. Just in the last few months, climate scientists have warned that catastrophic climate change could be on the way and that the double hazard of heat waves and sustained drought could devastate harvests. I just did a story about that, the 1-2 punch. So in more than one climatic zone in the same season, and those landlocked rainfall catchment areas that are already dry are becoming increasingly drier, more parched. And so basically this study, actually examining some collected data, is matching predictions. So over the same few months, researchers have established repeatedly that storms of the future will be worse. More devastating flash floods, excessive rain, boom, runs off, can be expected. And in one of the world's driest continents, Australia itself. Less water available. Of all rainfall, only 36% makes its way into aquifers, streams, and lakes. The remaining approximate 2/3 seeps into soils, grasslands, and woodlands, but more soil evaporation means less water is available from river supplies for cities and farms. U.S. researchers have already confirmed that if soils are moist before a storm, 62% of rainfall leads to floods that fill catchments. If soils are dry, only 13% of the rain leads to flooding. It's a double whammy. This is Professor Sharma saying this again. Less water is ending up where we can't store it for later use. At the same time, more rain is overwhelming drainage infrastructure in towns and cities, leading to more urban flooding. Small floods are very important for water supply because they will refill dams and form the basis for a water supply. Professor Sharma is continuing. But they're happening less often because the soils are sucking up extra rain. Even when a major storm dumps a lot of rain, the soils are so dry they absorb more water than before and less reaches the rivers and reservoirs. We need to adapt to this emerging reality. But it also less makes it into the aquifers. Again, we're seeing two things here. We're seeing the situations with the rivers and the aquifers and what's happening with the soil. It also a lot depends on how much rain comes down. Does the amount of rain that comes down overwhelm the system, the ecosystem, such that it can't absorb that water, even if the ground is dry, and it runs off and you get mass erosion? That's another distinct possibility. So that's basically what the first study is looking at. The second study, is found in the journal Geophysical Research Letters, researchers in Germany. They analyzed data from 50,000 weather stations worldwide to measure rainfall on a monthly basis. The U.S. has seen a more than 25% increase of record wet months in the eastern and central regions between 1980 and 2013. Argentina has seen a 32% increase. Central and Northern Europe, the increase is between 19 and 37%. In Asian Russia, has been about 20%, basically Eastern Russia. But in Africa, south of the Sahara, the incidence of very dry months has increased by 50%. This implies that approximately 1 out of 3 record dry months in this region would not have occurred without long-term climate change. This is a statement from Jim Massa of the Potsdam Institute for Climate Impact Research. The Potsdam Institute for Climate Impact Research is a major institute. They do a lot of climate change research into many areas of climate change. Generally, land regions in the tropics and subtropics have seen more dry records, and the northern mid to high latitudes have more wet records. This largely fits the patterns that scientists expect from climate change caused by humans. That's Dr. Kumu's statement. His colleague and lead author Joshua Lehman said, normally record weather events occur by chance, and we know how many would happen in a climate without warning, it's like throwing a dice. On average, 1 out of 6 times you get a 6. But, he continues, by injecting huge amounts of greenhouse gases into the atmosphere, humankind has loaded the dice. In many regions, we throw sixes much more often, with severe impacts for society and the environment. It is worrying that we see significant increases of such extremes with just 1 degree of global warming. 1 degree C. Imagine what 2 and 3 will bring. So, what's the bottom line of all this? As I just discussed with you, the aquifers are having issues. The soils, whether they're wet or dry, they're evaporating. The dry soils, when it does rain, they soak up the water, but it doesn't reach the aquifers because those dry regions are becoming drier. The wet regions, especially areas, the regions right around the rivers and lakes, the riparian zone, may see more increased precipitation, but the ground's so wet, if the ground is dry away from the immediate riparian zone, it can be absorbed, not refill the river, but there also can be flash flooding. So precipitation patterns are changing and increasing, but we're not able to capture more of that water, be it in the groundwater system or just being lost runoff. Is basically what's happening. And this will have detrimental effects in years to come. So, thank you for your time. Talk soon. Hey folks, this is Jim here reminding you to subscribe to this channel, to share my videos, tell others of the work that I do here. I also ask that if you are not already a patron at Patreon, to please consider becoming a patron at Patreon. You can find the information in the description box below the video. I'm asking you to help support the work that I do. I do not take any money from corporations or from any other sources, so the information I share with you is the actual science as it comes out of the peer-reviewed journals. So there is no BS, there's no propaganda, there's no agenda. It's just I present the science and I explain to you what it means, or at least my interpretations of it, based on my own experience as a scientist. I want this channel to grow. I consider, while I discuss many different topics here, you notice I do focus a lot on climate issues. I consider climate change to be the most pressing issue facing humanity today. Thus, I consider it important to disseminate this information to a wider and wider, more and more people. And I need your help to do this. So, yes, please subscribe. Please tell others of the work that I do here. Please share my videos on social media platforms, with your social media groups, what have you. We need to get this information out there. So for those of you who are supporting me on Patreon, I thank you greatly for your support and continued support. It does mean a lot to me. So together we can get this information to more and more people. Thank you. Thank you for your support.